Okay, so I'm gonna pick one. And this is medium. Looks good. And this is the time. Okay, so smallest missing non-negative bars that time. Smallest missing non-negative integer after operations. Very long title. You're given in zero index integer array nums and integer value. Okay. In one operation, you can add or subtract values from any element of nums. Okay. For example, if nums 1 to 3 and value is 2, you can choose to subtract value from num 0, and then that's going to be 1, 1 minus 2. So I'm going to have minus 1, 2, 3. Makes sense. And then the max minimum excluded of any of an array is the smallest missing non-negative integer in it. What? For example, max of minus 1, 2, 3 is 0. Why? Or max of 1, 0, 3 is 2. I have no idea what they're talking about. Max array is smallest missing non-negative integers. Okay. Right. So smallest is 0. I see. Okay. So minus 1 is not count because it's negative. And then the max of, in this case, you have 0, you have 1, and then the next smallest missing number is 2. Okay. Interesting. Max. Okay. I've never used this term max, but return the maximum max of nums after applying the mention operation any number of times. This is a very weird question. This is a very weirdly complicated question. Maybe I can just look at the example. So I'm gonna give you nums, these kind of value, the arrays, and the value going to be 5, and somehow I need to output 4. I have no idea why. So one can achieve this result by applying the following operations. Sure. Add value to nums1 twice. So here, and then that's going to be 0. Yeah, 5 plus 5 and 0. And then subtract value from nums2 once. Okay, so originally I have 7 and subtract 5, that's going to be 2. And then subtract value from nums3, that's 0, 1, 2, 3 here. That's going to be twice. So 13 minus 10, that's going to be 3. And then the max of nums is 4. Why? Because you have 0, 1, 2, 3, and then the next smallest number is 4. It can be shown that 4 is the maximum max. So, and okay, what should I do with this? So I can do this kind of hardware subtract operation, and then I understood the operation, and also I understood the max. And then what we want to achieve is we want to get the maximum max from nums. Oh, okay. Yeah, I think I eventually understood. Okay, so example one looks good, even if I don't know how to solve it. For example two, it's going to be the same array, and then I'm going to have value 7, sure. And what's going to happen is one can achieve this result by applying the following operation: subtract value from nums to once, 0, 1, 2. So that's going to be 0. And then max of nums is 2. It can be shown that 2 is the maximum max we can achieve. Why can you know that? Why can you know that? Why can you know that? So, okay. So basically, to achieve maximum max, I need to create some kind of steps, which is starting from 0. So when I see, let's, okay, when I see the minimum non-negative this is 1, so that's obviously telling me that I have to create 0. And then you can create 0 by subtracting 7 here. And then I already have 1, and then to maximize max, the next thing I have to do is I need to create 2 somehow. And can I create 2? So if 7 multiplied by 2, that's going to be minus 1. And this is going to be 1. This is going to be minus 1. This is going to be minus 10 plus 7, minus 3. Minus 3 plus 7, that's going to be uh, 4. So it looks like I cannot create 2. That is why I, I, I need to put 2. Wow, I don't know how I can create that kind of algorithm. Maybe I'm going to go back to the, let's see the constraint. But it could be length. Length and value could are just positive, and the number could be negative. Yeah, I see them. I saw negative numbers. Well, I don't know how to solve this. Um, so when I going back to the example one, it's there's no 0, so I have to create 0, and I can create 0 because this modular 5 is 0. That is why I can create 0. Uh-huh. Okay. Yeah, my brain started working. So if I do modular, um, so what's the next number? This one. So 7 modular 5, that's going to be 2. So I can create 2. And then the next one, this one. So 30 modular by 5, that's going to be 3. Okay. And then there's no next one because this gonna modular going to be 1. This modular going to be 3. Okay, so I think the key to this question is number, num modular value. This should be an important step for this question. Basically, I can create the next number, right? And then I don't care about the negative. I actually don't know what's gonna happen if I modular like um, like if I do minus 10 by modular, is it going to be negative? So if I do this, what's going to happen? I don't know. So that's going to be, this is not a good example. Maybe I'm going to give minus 9, for example. What's going to happen? So the output going to be positive, sure. So I don't have to care about this sign. So what should I do? What should I do? So I just take modular each element, right? And then I can create 1, 0, 2, 3, 1, 3, right? And then I just sort it. Yeah, it looks like I just sort it, right? And then sort it, I can get like 0, 1, 2, 2, 2, 3, maybe 0, 1, 0, 1, 1, 2, 3, 3, right? And then I try to I'm just starting from 0 and scan the array, and then right, like sorting. So I just I just have to create example. So if I have this and then modular, right? And after modular, this is gonna be 1, 0, 2, 3, 1, 3, and then I'm gonna sort. and this is going to be 0, 1, 1, 2, 3, 3, right? And what I have to do is just starting from counter 0, counter 0, counter 0, right? And then if 0, there is 0, I can go to the next and then implement this counter. And that's going to be 1. I have 1. So uh, I can go to the next, and the counter going to be 2. But if this current number is the same as the previous one, I'm going to just skip it and I'll go to the next. And then now counter is here, we increment it to 2. So it's the same number, so I can go to the next. And it's already increment, so it's the same number. It's the same as previous number. I'm going to go outside. And then when I go outside of the array, this is already implemented before, so I can just return this answer, right? But in the case of this example too, so if I apply modulo, this is going to be 1, and then the value is going to be 7. So this is 1, 3. Is it 3? I think it's 3. 3, 0, and fuck, 6, 6, 6, 6 and 1. And then if I solve this is going to be 0, 1, 1, 3, 6, 6, right? And then the counter starting from 0. And we have 1, it's going to be 1. And then I'm going to scan this. It's the same, so I'm going to go to the next. And then now, okay, so I think, right, so first I need to check, do I have to do such annoying steps to scan everything? Maybe no, I think after this, um, um, after this, maybe I can take the hash set to make it distinct. But either way, it's not really helping me a lot. So I can take a hash set, but so so but I want to just stick to the current approach. So 0 and then increment it to 1, and it's the same, so I can go to the next, but it's the same as previous one, so I'm going to go to the next. And then it's different from the previous one, and then the counter is 2, but 2 is different from 3, so that is why we can say 2 is missing, so we need to output 2. So we can use hash set, but just scanning, we can still solve it. So the time, because I'm sorting, time gonna be n log n because I'm sorting, and then the space going to be, I mean, I can just in place modify this num, so in that case it's gonna be 1. If they allow me to do in place modify, but I think in this case I don't need the previous ones to give a number as array. So I think I'm going to just in place modify to save space. Okay, so I think I can. It doesn't look so bad. So I hopefully this question can pass all the test cases. I guess at least I think I can pass these two examples. So I think I can start coding. Okay, so what I'm going to do is just scan the iterate this nums array, about range length nums, and then I'm going to just in place modify by nums I modulo by value, and then as I told you, I'm going to just solve this array, and then what I'm going to do is So counter is actually going to be the answer. So I'm going to just initialize by 0, and then eventually I'm going to just return this. And then what I have to do is I'm going to iterate again. I'm going to in range len nums, right? And then so what I have to do is if nums I is equal to uns, so in that case I can increment by uns, right? But as I told you, I have to check. It's fine. I can just start from simple. So like in this 0 case, it's the same. So I'm going to increment, and I'm going to the next, and that's 1. And then this is supposed to be 1, so I can go to the next. And then now it's the same number, so I need to skip that. So if I is bigger than the 0, and also nums I is same as the previous number, I'm gonna just skip it, and I also don't have to increment it. And then now I can count to 2, it's the same, it's implemented right. And then eventually I'm gonna go outside. So if I'm able to go outside, I actually have to implement it because there was no 4. So it's okay to implement. No, it's already, yeah, it's already implemented, so I don't have to do that. What I mean is at the 3, it's already implemented to 4, right? And then the example 2 case, I want to drink coffee. The example 2 case, I'm gonna 0 is the same. And then the 1, 1, 1 is skip. 2, okay, so 2 equal 3, yeah, right, 3 okay, so here I'm gonna create if nums I is not equal to uns, it's already found a missing one, so I'm gonna immediately return missing number. So I think that's gonna work for 2 test cases. It's working, but the question is whether this is going to work for every test cases. So in this case, expected to be 5. Why? What? Expected to be 10, and I'm 5 is way different. Well, already I kind of passed half of it. Why is that? It's not that simple, maybe. Uh, okay. What? Okay. Sure. I mean, what's missing here is, okay. What's missing here is, like, if I take modular, this is value is 5, and actually it's not going to change at all. Like, modular is the same, and then if I sort this gonna be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, right? But what's saying here is, I guess, like adding 2 times thing, maybe. Right, because, okay. Right, so okay, if I add 5, okay, addition, okay. So if I add 5, this is gonna be 5. This is gonna be 6. This will be 7. This will be 8. This will be 9. So the missing is is the next smallest one. It's going to be 10. Ah, okay. Okay. I couldn't solve. Um, what should I do with this? Damn it. Um, what should I do with this? Okay. Right. So I think after modular, I'm gonna add one more step. Okay, that's good. That's reasonable. Okay, so if um, sure. Okay. So for example, like in this case, after sorting, if I have duplicate number, I can actually add the given value, so that I can create this kind of array and then sort again, and then this approach. Well, that looks kind of ugly. That looks kind of ugly, but it looks like it's gonna work. No, it's not gonna work. Right, so we actually have to create addition by the number of duplicated. What I'm saying is for them, let's say we have 3, 0. What we have to do is 0, 5, and 10 if the given value is 5. Uh, and then eventually I can do the scanning thing. So apply modular, and then I need to, for the duplicated numbers, I have to apply the addition by the number of counts. And then I can do the final scanning. Wow, the fuck, I cannot. I feel like I'm kind of wasting a lot of time. But it sounds kind of. But how can I modify that? Um, how can I create such kind of array? If that's the same, I'm gonna if when I scan, if the same as the previous one, I'm gonna add 5, and then after add 5, if that's same, I'm gonna add 5 again, but that's now it's gonna be multiplied by 2. I feel like there's a kind of easier way to do that, but I cannot think of it. Um, what should I do with this? I mean, up to the point of applying modular, it looks good, but um, well, maybe there's a better approach. Like when I get 2, 3 modulars, it's giving me it's what was this is 5. So actually, what I have to do is um, right. So modular. Okay. Uh, this is 2 and 3. 13 divided by 5. It's going to be 2, and then remaining going to be 3. And then in this case, 1 remaining 3. So okay. It's actually just get the remaining multiplied by ah okay. With that yeah, okay. Yeah, I don't have to do such complicated. But if I do with this, we're still gonna. No. Yeah, I think after applying modular, just before sorting, I think I'm gonna just create a hash map. So modular, um, um, apply modular to every nums to num, and then hash map, hash map, gonna be key will be the after modular noun, and the value is going to be the count, and then from hash map create array. So that's going to be like array append so key multiplied by value. Yes, and then decrement value, and continue until hash map is empty. It's already over 25. I actually wanted to solve 25, but just I feel like I can solve it, so I'm gonna just keep continue. So modulos, and then just gonna be the empty array. So I'm not gonna do the implies modify, and then instead I'm gonna just save this to the array, and then before sorting, I'm gonna create the counter. So counter gonna be collections counter modulos, and then from here I'm gonna create a new scan array that's gonna be empty, and then I'm gonna just key value in counter items, and then while value is bigger than 0, I'm gonna what I have to do is count key multiplied by value, and that should be saved to this array, and then I'm gonna just decrement this value, and when 0 we're not gonna do anymore. So I think this scan array contain what we want to have. Let's see this one. And then I actually want to save this very precious test case. So save here, and then this is going to be the 5. So I'm not going to do this for now. Actually, I need to put this one. So if I do this, if I go to the case 3, it doesn't look good. It doesn't look good. Yeah, it doesn't look good. Oh, why? I think I made some kind of mistake. So I'm gonna put the counter. Counter looks good, 0, 2, 1, 2. That looks good. But the problem is I failed to create this scan array, which looks like this kind of array. I wanted to create that kind of array. So why is that? It's because we have no, this is wrong. So this is I think it's just a math. I think I have to use the value. So what should I do? See, what? What? Let's say like if we have like 0, what I want to do is value -1 multiplied by value, and that should be adding to key, right? So 0, and now we have 1, so we can add one value. That's going to be, let's say it's going to be 5, and then now v is 1, so this is going to be 0, and then that's going to be 0. Yeah, so just about math. So now if I go here, I have nice looking array. Okay, I have nice looking array. So what I have to do is going back to the previous approach, and then I'm gonna, oh no. I'm gonna sort it and then do this thing, and hopefully that's gonna give me answer, please. No, so okay. 0, 1. So original array became worse. Why is that? Previously I was 0, 1, 2, 3. Well, that's supposed to be 4. Why am I putting 0? Because this is it's not nums. I need to go to the scan array. Right, and then this is also I need to name everything. I take it too much time. It's like more than 30 minutes. That's too long. That's I'm so failure. I'm so failure. Uh, it sounds like there's a better approach. So if I do this, now everything is working, and I hope it's gonna work for all the test case. So I'm gonna just okay, eventually. So I don't know. Memory, yeah, because I created the new array, but it looks like I can just in place modify, and I can go there maybe, and then I also create in the hash map. So maybe there's some kind of way to do approach in place modify and then not creating the hash map. In the runtime, I think these guys are sorting, and this should be maybe or any approach exists maybe or like using heap. I actually don't know. But it looks like there's a better approach, like saving memory and also time. Maybe I didn't have to sort. Yeah, basically that's it. I hopefully I want to solve within like more half of the time, but I couldn't do it. So I just yeah, basically that's it. Yeah.